you were to do this, you could then type cargo run, and it will compile your program, because Rust is a compiled language, and then print out hello world. And so it also creates two new files. So there's the target directory, which is where it puts all the compiled output into, and then a cargo.lock file. And so when you list your dependencies, you're like, I would like to use some version 1 of the dependency, and it will look up and say, oh, you wanted to actually use 1.2.3. It'll save that in the lock file, so that way you can, if there's a new version that comes out, it won't automatically update for you. You have to say, like, I want to opt into the new version. That helps keep dependencies manageable. And so yeah, you can try printing out some other stuff as well. I work on documentation, so I always like to talk about using the documentation, because that means you get to use my work. So there's a website, doc.rustlang.org, that lets you read the docs, but also it comes installed with Rust. So if you type rust.doc, it'll open that up locally. You can read on those things, and you can check out the standard library or whatever else. One of the big things that we're trying to work on this year / maybe sort of next year is doing a better job of having non-English, like, everything. So the website is the first sort of thing. The website has translations on it, but I implemented it and I sort of did a bad job, so it's kind of like a pain in the butt to actually edit. We're sort of working on trying to figure out how to have more than just purely English. So if you like writing documentation, you want to submit some non-English docs, we're not ready yet, but hopefully soon in the future that will be a thing. So we really care about international, everyone being able to understand what's going on. Okay, so we're going to talk a little teeny bit about the syntax and concepts that are the same as other programming languages, so you kind of get a little feel for Rust, and then I'll switch into the addition stuff that happens. So this will give you enough information if you haven't written it before to sort of understand what I'm talking about. So we have comments. You can put a double slash at the start of a line, and then the compiler ignores everything else to the end of the line. It's pretty common in many languages. There are actually a bunch of kinds of comments. So for example, documentation comments have 3 slashes, but this is not a talk about comments. I don't want to bore you with talking about comments forever, so let's talk about that. For variables, so to introduce variables, you say let, and then the name of the variable, an equal sign, and then whatever it is. So in this case, Ashley, and then age being 30. And when I talked about macros before, the reason that that works is so you can put stuff in your println by using these little curly braces, and then the variables go on the end there. And so what happens is the macro will actually check that you've passed in the same number of things as the number of curly braces. It'll actually error when you try to build your program if you mess up those numbers, which is kind of neat. And so this will print, hi Ashley, you are 30 years old, which you are not anymore. Yeah, so it's kind of like how that stuff sort of works. Oh, you also notice that there's no types here, but Rust is a strongly statically typed language, so we infer the versions of types. So this will infer that this is a string and infer that this is a number, specifically a 32-bit integer. And so you write the types for function signatures, but you almost never write types inside of the function body. It's like a nice, it's nice to not have to write them all the time, basically. So it sort of it feels much more like a dynamic language, even though it's typed. And so another interesting thing about Rust is that if you try to run this code, it will not work. So we say we have 100 apples, and then we say apples plus equals 50 to add 50 to them. In many languages this would work, but in Rust this does not work. And the reason is that variables are immutable by default. And so you have to specifically say that I want to be able to change this variable by typing let mute apples instead, and now it will let us change this code. So everything is immutable, and that's like a really nice for a number of different reasons. A lot of people that come from languages like Ruby are very confused at first, but after you program in Rust, most of your variables end up immutable. Like a lot of people think, oh, does it mean I'm going to have to type all the time? And generally that's not actually true. So it's kind of an interesting aspect of everything. I talked briefly about types before, but some example of common types. So numbers, you actually have to say how many bits the number is, so there's no sort of number type. So we have a 32-bit integer, and there's unsigned and signed. And what that means is a signed number can be negative or positive, and an unsigned number can only be positive. This matters for low-level things that most of the time you don't need to super care about. We also have floating point numbers, so if you want something with like 1.0, then that would be a floating point number. And We have two different string types. So there's a string and an ampersand stir. I will talk about those briefly, but this is one area that people struggle with when they're starting with Rust, is there's not just one string type. There are good reasons for this, but it's hard when you're starting out to explain why, so just know that there are two string types. And then like bool for booleans, for example. And you can make your own types and do all sorts of other things, but I'm not going to get into that right this second. We talked about type inference already, so I'm not going to get into that. Here's an example of a function that takes a number and returns a number back. So you can see we still have the fn keyword, but now we have n:32 for n being a 32-bit integer, and then this little arrow, and then the return type for returning another 32-bit integer. So that's kind of a little more than just the main function we saw before. And then we add 50 to n, and you notice we don't say return here, and that's because in Rust everything evaluates to a value. So since this is the last line in the function, the value that gets evaluated here is the value that's returned. So this will end up being 50 to whatever number it is. So you add 50 to 100, and you're going to get 150 back and print it out. It's kind of the basic function syntax. We have if. So for example, you can say if n is less than 150, do this, and else if n is less than 200, do that, and then else for everything else. That's pretty common for many languages. There's a match statement, which I could talk for an hour about just the match statement and how cool it is. It's something that one of the people that works at NPM learned some Rust, and she liked switch so much, or match so much, that she's trying to add it to JavaScript. Like she's like going through the JavaScript standards body to get it in there. So people get really passionate. But what it lets you do is, so here we have an age that's 167, and then you can match on it, and then each one of these things is kind of like putting a bunch of if statements into one thing. So if it's between this range, then that happens. If it's in this range, that happens. And then the underscore is for like anything else. It's really the else case. There's so many things you can do with this, not just ranges, but like when you have more complicated structures, you can like check that they're sort of the right way and do all these things. And there's a lot going on in that. We have arrays, kind of like arrays in other languages, but worse. It's true. Arrays have to be a fixed size, so you can't add or remove things from arrays, and that means they're a little awkward to use in today's Rust. Sometime next year they'll get easier to use, but I'm not going to get into that right now, but they are kind of a little bit of a pain. So for example, you declare an array with the square brackets and commas. This is an array that has 3 things in it, and then you can access parts of the array using the square brackets and a number, just like many languages that have this sort of thing. Print that out. I'm not going to talk about this. Vectors are what most people think of when they think of arrays. So this is something you can mutate, make smaller and make bigger, add stuff to, remove stuff from, all that shenanigans. So it's kind of common when people start off, they think they want an array, but they actually want a vector. And you can create a vector with this vec macro, so it looks almost the same, except for it's got the little vec in front. And then you can, set a particular value, or you can call push to add something onto the end, or pop to remove something, all this kind of stuff. So they're really flexible and used quite a bit. Loops. So we have for loops, but we don't do the C-style for loop. We have like an iterator-based one. So you say for I in these numbers, and this will go over an I always set to 0, and then 1, and then 2, the whole way up to 9. And you can loop over like a list. So here's some people's names, and you can list over them and print out their names and do that kind of stuff. And we also have loop for an infinite loop, and while, and break to break out of a loop, all that kind of stuff. It's sort of in other languages. Okay, I think maybe this is the last thing before I start talking about the other addition stuff, since this is probably enough context now for you to maybe sort of get the basic idea. We have iterators. So iterators let you kind of like process lists in an interesting way. So for example, here we're going from numbers from 0 to 10, but we're calling filter on that. And so filter takes a function that returns true or false. And if the function returns true, then you get the number. If it returns false, you skip the number. And so this is a closure. If you've used Ruby, this syntax looks familiar. And if you're not, it looks totally ridiculous, sadly. But the pipes indicate the arguments to the function. So here, this is taking a function that takes one argument x. And if x modulo 2 is equal to 0, then it's even. So we print every even number. And there's map to like transform numbers. So this would take every number from 0 to 9 and then multiply it by itself, and you would get that sort of stuff out. And then we also have fold which takes some sort of initial number 0, and it calls this function with each item in the element to like add it all up, so it should sum the numbers from everything. So there's a lot of stuff going on in iterators, and they're kind of really cool. They take a little while to wrap your head around if you haven't used a sort of functional language. Okay, I think I'll talk about enums real quick. This is also one of my other favorite features of Rust. And so an enum lets you have something that's like, it's either red or yellow or green. So we can say that like a variable is equal to the green version, and this is where match starts to get really cool is enums. So we can match against the enum, and it'll, on red it'll do this, on yellow it'll do that, on green it'll do that. But what's cool about this is because the compiler knows that you have 3 versions, it will make you put all 3 down here. You can't forget one, which is really nice. You can say, I don't care, like if you only wanted to do red, you could use the underscore, and that says like I take care of all the other cases, but it just makes sure that you check all of them, which is really, really useful when you're trying to write like robust code. It doesn't let you skip them, which is kind of cool. And the other cool thing about enums is it's not just this whole like name thing. You can also put other values into an enum. So for example, here we have a game type that has a single player game, but then also a multiplayer game that holds the number of players in the game inside of it. And so this is where match starts to, you can see a little more of the match features. So here, if it's a single player, we print solitaire. If it's a multiplayer where this number is 2, then we suggest checkers. If it's 4, then we do this. And if it's some other number, then we set this variable num, and we can use that inside the block. So it gives you this really big power to sort of like create these sort of things and kind of tear them apart with these sort of super if statements. After enums is, talk about, there's tests. Okay, where's the struct thing? I forget. We didn't talk about structs somehow. Anyway, okay, that's enough for the little intro to syntax. Since most of you raise your hands, I think that's a little bit of a review, but hopefully that gives you some context for these things. And we can give you a link to these slides if you want to go through all the different situations, like option is how we do null and all that stuff. So, all right, let me talk about what we're actually going to do